MATLAB has one input statement or function, which is called input, which allows the user to enter something from the keyboard. The call to the input function is in an assignment statement. What it does is it prints the prompt, and then when the user enters a value, it stores that value in the variable that's on the left of the assignment. Like the output functions, input in MATLAB can be used in the command window, but it really makes sense in scripts. So here's an example of prompting the user for a number. And again, we can do this in the command window. So in an assignment statement, I have a variable age, gets the value of. Then the input function, we pass to it a string, which is a prompt, and then suppress the output so we don't see what is stored in the variable. So again, with the input function, you pass the prompt to it. So when this is executed, the prompt comes up, enter your age, and then I had a colon and a space, and then the user types in a number, and that's going to get stored in the variable on the left, but since we had the semicolon to suppress the output, it doesn't come back and show that, but it did store the 33 in the variable age. Now there's only one formatting character that you can use in the prompt, and that is the new line character. So if I had in the prompt, enter your age and the new line character, when we execute this, it's going to say enter your age, and then the new line is going to move the cursor down here, so when the user enters something, it's going to be on the next line. And again, it's going to take that 33 and store it in the variable on the left, in this case, age. Personally, I think it looks a lot better if the input is on the same line rather than on the line underneath. Now that was for prompting for a number. If you're going to prompt the user for a character or a character string, you have to pass a second argument, which is quote s quote, to the input function. So for example, if I say enter your name and I want the user to type in a name, then I pass two things to the input function. So the first is the prompt, comma, and then the second thing that we pass to input is this quote s quote, which says we're expecting character or string input. So when this is executed, the prompt comes up, enter your name, and then the user typed in a string, and that gets stored in the variable, in this case name, on the left of the assignment. So this is not strictly necessary, but if you don't include the quote s, the user has to know to put quotes around what they enter, which is not really a great idea. But it is possible. So if we said enter your name, and then the user entered a string, including the quotes, that would also work. But again, usually the user doesn't know to do that, so it's much better to pass the second argument, the quote s quote, and then the user just types in a string without the quotes. The input function in MATLAB can only read into one variable. So you have to have a separate input function for every value that you want to read in. So let's say, for example, we want to prompt the user for x and y coordinates of a point. We'd have to do it in two separate assignment statements using two separate inputs. So we'd say input, enter the x coordinate and store whatever the user enters in a variable x, and then a second input, enter the y coordinate and store whatever the user enters into a variable y. So again, an input function can only read into one variable. However, you could read into a vector, but that is one thing. So we could say input, enter a vector, and then the user would have to know to type in a vector. For example, you could enter using square brackets, and that is one thing, a vector, which gets stored in the variable on the left. And in this case, I did not suppress the output here, so we see what is stored in the vector variable when this is executed. So here's an example of a script that has both input and output. It prompts the user for the length of a side of a square, and then it prints the area. So we might store this in a code file called areasquare.m. So these are all of the lines in our code file. First of all, we're going to display an instruction that says we're going to use units of meters. Then we have the input function, which prints the prompt, enter the length of a side, and when the user enters that, that'll get stored in the variable side. Then we're going to take side squared and store that in a variable square area, and then print out the results in a formatted way using fprintf statements. The print for a square with a side of, and then the value of side, the area is, and the value of square area, m squared, short for meters squared. So again, if we had that in a code file called area_m, we could display the contents using the type command, so type area square without the .m, and that will display the contents of the code file. And if we want to actually execute the code file, again, give the name of the file without the .m, and that will chug through and execute each of the commands. So first of all, it's going to display, we'll use units of meters, so it prints that out, we will use units of meters. And then the input function prints the prompt, enter the length of a side, and the user entered 4.1 for the value of the variable side. Then it calculated the square area, but suppressed that result, and then printed everything in a nice formatted way using the fprintf. So it prints for a square with a side of 4.1, the area is 16.81 m squared.